Hi! In this video we'll be learning about simple and compound interest. To make the most of the learning experience, you may want to consider buying a copy of the book on which these notes are based, as well as a professional calculator. Just have a look at the links in the description of this video. The first part of this course is about money and interest. A money market involves two players, a borrower and a lender. This market is about loans. A loan is characterized by a time horizon ending at a period called maturity, an amount known as principal, as well as a compensation known as interest. In order to keep track of the amount due by the borrower over time, I'll define the amount function A. Of interest are the principal, which corresponds to the amount function evaluated at the period t equal to 0, as well as the accumulated amount, which corresponds to the amount function evaluated at maturity. That is, it is the amount to be paid by the borrower to the lender at maturity. To keep a record of the interest incurred in the TIF period, I will define the function I, which corresponds to the variation in the amount function at every point in time. If the initial principal is of 1 unit, we denote the amount function by lowercase a and call it the accumulation function. The accumulation function and the amount function are essentially the same thing, apart from a factor c, which represents the principal. With this framework in mind, I can already introduce you to the two most common ways of computing interest. Namely, simple interest, in which case interest is proportional to time and principal remains unchanged. In this case, the accumulation function is simply a line with the slope of that line being controlled by the rate of interest. And in this case, the amount function is also linear, whereas the interest function is constant and it depends on both the principal as well as on the rate of interest. Now, let me introduce you to compound interest, in which case the accumulated amount at the end of the year is the principal for the next year. So it's really compounding in a literal sense. That is, your accumulation function is exponential and so is your amount function. Here is a chart comparing accumulation functions for simple interest against compound interest for rate of interest equal to 7% over a time horizon of 20 years. As it can be seen, compound interest always dominates simple interest. Okay, so time for an exercise. You may want to pause the video now so to work out the details on your own. Okay, ready? Let's go. In order to compute the accumulated amount at maturity, I always recommend you in this type of exercises to think about the situation where a principal would be equal to 1 and always just work with the accumulation function, because in the end you just have to multiply that by the principal in order to get the amount function. Okay, if you proceed in that way, you just have to compute the accumulation function, which is linear, as you know, for the case of the simple interest method. After you multiply it by the principal, which is 30k, you get the final result that is equal to $37,800 US. Interest rates are constant per annum and they are simply given by the product between the principal and the rate of interest. Let's now move to compound interest. In terms of the accumulated amount at maturity, I recommend you again to proceed in a similar way as in the previous case, in the sense that start with the accumulation function, that is, just start with the case where principal is equal to 1, and then you just have to multiply by the principal in order to get the amount function. If you proceed in that way, you get the result immediately. In terms of interest charges, okay, so for the first year you have to do exactly what you've done in terms of this simple interest. Now, in terms of the second year, you have to keep in mind that the difference becomes that you have to update the principal, in the sense that you, rather than using the principal for the first year, you should use in the expression the principal for the second year, and you then have to multiply again by the interest rate. And similarly, you can compute the interest for the third period as well as the interest for the fourth period. Okay, we're done for now. In the next video I'll be telling you how long does it take to double your capital.